What's up, everybody? This is John with John Fair Innovations bringing you another math lesson. And today I'm going to be teaching you how to use the Minima and Maxima test. Now, before I get to the video, if you enjoy it, do make sure you hit that thumbs up button, leave a comment on maybe another math topic you'd like me to tackle. And if you really enjoy this video, do make sure you hit that subscribe button because it really does help out the channel. So if you've done so already, thank you so much for your support. We really appreciate it. Now, today I'm going to be teaching you what's called the Minima and Maxima test. And all this is this is a way for us to determine if a function has a minima or a maxima. So what we mean by this is when we're dealing with the second derivative of a function. So the second derivative of a function will let you know if something is a minima or a maxima. So we're dealing with the idea of the highest and lowest points of a function. So let's say, for example, if you have the second derivative and it creates a positive number, then this is going to give you a minima. So you're going to have a graph that looks like this, where it's kind of like a U shape, and you'd see there that it's going to have some value that's going to be the lowest point possible. So this would be your minima. So this test lets you know whether you're going to get a minima or a maxima. So if you did your second derivative and you got a positive number, that would let you know that you have a minima, for example. Now, if you did your second derivative and you got a negative number this time, well, now you'd be getting a maxima. So your graph is going to look a little bit like this. So it's going to kind of look like a sad face or an upside down U. And again, you're going to see here that you're going to have some point, some value that's going to be its highest point. So this test lets you know whether you're going to get a high value or a low value. If on the rare occasion you get a 0, what that means is that the test has failed. So your function doesn't have a maxima or a minima. And I'll give an example of that later on as well. But most of the time when you're doing this, you will be getting a minima or a maxima. So let's say we have this equation. We got negative 2x squared plus 5x minus 10. So what we're going to do is we're going to find the first derivative. Now we're just going to use the number rule today. So what we do is we take our indice, we multiply it by the front, and we subtract that indice by 1. So in the first case, it's going to be 2 multiplied by negative 2 and x to the power of 2 minus 1. Next one, we have x to the power of 1. So it's going to be 5 times 1. X 1 minus 1, and then the last one we're going to have 10 times 0 because there's no value, so it's x to the power of 0. Now we don't really worry about writing this x to the power of 0 minus 1 because any time you find the derivative of a constant, so one that doesn't have an x value, it's just going to be 0. So when we expand that, it's going to be negative 4x to the power of 1 plus 5x to the power of 0 minus 0. Now, x to the power of 0 is always 1, and x to the power of 1 is always x, so that's just going to leave us with minus 4x plus 5. And we do the exact same thing again. So x to the power of 1, so that's going to be negative 4 times 1, x 1 minus 1, and because now 5 is a constant, we simply just multiply that one by 0. And then that's going to now leave us with negative 4x to the power of 0 plus 0, so it's just going to be x to the x to the power of 0 times negative 4, which is just the same as negative 4. And so now we've got a negative number, so that lets us know that this function is going to have a maxima in it. So we know that there's going to be some value where it's going to be the highest point possible. Now dealing with a different function, let's say we have this function now, we have y equals 3x squared minus 10x minus 18. So using the number rule again, taking the 2 down, so it's going to be 2 times 3, x 2 minus 1, minus 10 times 1, x to the power of 1 minus 1, and then a negative 18 is a constant, so we just multiply that one by 0, and then that's going to leave us with 6x to the power of 1, minus 10, and then now we do this second derivative, so we do the same process again. So that's going to be 6 times 1, because x to the power of 1, x to the power of 1 minus 1, and then we're going to have minus 10 times 0, because 10 is a constant, leaving us with the value of positive 6. So now we have a positive this time, so this lets us know that this function is going to give us a minima. So we're going to have some value that is going to be the lowest point possible on this function. Now let's say we have this last function. We have y equals 3x minus 10. So this time we're dealing with a straight line. It doesn't have a power of 2, 3, anything like that. It's to the power of 1. Anytime you have a function like that, it's just going to follow your y equals mx plus c formula. So this is going to give us some sort of straight line. So it's going to look something like this. Now, when we're dealing with a minima and maxima, we're dealing with the concept of a highest or lowest point. But as you can see on a straight line, this is going to go in both directions forever. So we really can't determine a highest value or a lowest value. They go in each direction infinitely. There's no dips, there's no curves, there's nothing like that. Now, and the maxima minima test represents this. This is why you get a 0. So if we look at it, if we did the test, for example, we can go 3 times 1 multiplied by x to the power of 1 minus 1, multiplied by 10 times minus 10 times 0, because 10 is a constant, and that's going to leave us with simply 3. And then that, if we do the derivative again of that one, so that's going to be 3 times 0, and that's going to leave us with 0. And so as you can see, this would be considered a test failure. And as you can see from the graph I drew before, we're never going to get a maximum number or a minimum number. They're going to keep going in the opposite directions. Well, hopefully you enjoyed that. Let me know if there's any other math topics you'd like me to tackle. But always stay safe, be kind to one another, and I'll see you next time.